Let's draw a tree with replacement and a tree without replacement. See how the trees are different. The situation is we're going to pull 2 marbles out of a bin. And the first time we do it, we will replace the first marble picked before drawing the second with a blindfold on. Now, our first pick has 3 possible choices: white, gray, and black. And then our second pick, because we're replacing, also has 3 choices. All right, I'm going to quickly write the sample space so we can see the sequence of what was picked. In the top branch we have white, white, then white, gray, white, black, gray, white, gray, 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 black, and so on. Alright, we'll use the fundamental counting principle to figure out how many different possible outcomes there are. As we can see, there are 3 choices for the first pick. Then once you replace, you'll still have 3 choices for the second pick. So 3 times 3 makes 9, and that matches the number of outcomes we see in the sample space. What's new here, though, is that we're going to try to calculate the probabilities of a sequence of marbles being picked. But this time, we're not going to just count them with the sample space. We're going to actually use a more advanced method, and it is the multiplication rule for probabilities, which says if you want to find the probability of A and B occurring, then you should multiply the probability of A times the probability of B given A. So it involves a conditional probability. Let's see how that would actually apply in this next question. Next question says, what is the probability of selecting white, then gray? If we simply follow the white path and then the gray path, we can see there's only one outcome for white, then gray. So we want the final answer to be 1/9. But we want to find it not just from the tree, because sometimes we don't have access to the tree. Sometimes the tree is too big to draw. So we want to use the multiplication rule above instead. What it requires is that you have 2 blanks, 2 things to multiply, just like above in the fundamental counting principle. But this time, they're actually going to be probabilities that will multiply. So what goes here for the first blank? It's the probability that white is first. Alright, so looking at the tree, we see that there is a 1 in 3 chance of white being selected first. So we'll put that down. Now we need to multiply by something. But it's not just the probability of gray being second. It's the probability that gray is second given that white is first. It's a conditional probability. So if white is first, and we do take this path right here, what is now the chance of getting gray after that happens? We can see from the tree, it is a 1 in 3 chance. Now we'll actually just multiply those. When you have multiplication of fractions, though, you want to multiply the denominators together and then multiply the numerators together as well. So we'll get 1 on top and 9 on bottom. It worked. It did give us the correct probability. All right, for the next one, it says, what's the probability of gray never being selected? Okay. Well, we don't want gray on the first pick, so there's a 2 in 3 chance that we won't get it. And then assuming that we don't get it, what is the chance of the next one not being gray? It reduces to 2/3 as well. And so our answer here will be 4/9. It's a fast method for finding probabilities without using a tree. All right, now the next question is a little tougher. It says, what is the probability of selecting at least one gray? Here, unfortunately, well, let's see if we could do it from the tree just for a minute. It's a little bit tougher. You have to circle any outcomes that involve a gray or 2 grays. Okay, there we go. Just from the tree, I see that the answer should be 5/9, but we don't always have the tree available. And doing it from the multiplication rule would actually be quite challenging. So I'm not going to do it that way. It's not really practical to do it with that. Instead, I'm going to use a technique that we had used in the past for finding probability of at least 1. If you recall, that technique had said the probability of at least 1 equals 1 minus the probability of none. That'll be the fastest way to do this one. So we had already found the probability of no gray above. We just got to do 1 minus 4/9. That'll give us the 5/9. But notice that that process could be applied even if our tree was really large. We wouldn't have to actually count the outcomes. We just have to use the multiplication rule to find the probability of no gray and then do our 1 minus to find the probability of at least 1 gray. All right, so next I'm going to do a tree, this time without replacement. On our first pick, we could get white, gray, or black. But once we do pick this one out, we're not going to replace it. So if we take the white path, then white does not get allowed to go back into the bin, which leaves our only possible remaining choices to be gray and black. If you take the gray path, on the other hand, then gray would be removed, and the only remaining choices will be white and black. If black is chosen first, then white and gray could be picked next. All right, so how many outcomes in the sample space? By the fundamental counting principle, we see that there are 3 choices for the first pick, but when you don't replace, you reduce the number of choices by 1, so there's only going to be 2 choices for that next pick. And 3 times 2 makes 6 outcomes. What's the probability of selecting white then gray now? Okay. I'm going to put 2 blanks down for my probabilities. First, we'll have to state the probability that white is first. Then we want to multiply by the probability of getting gray on the second pick, given that white is first. So successive events have to assume that the first event happened when you go to find that next probability. All right, our chance of getting white on the first pick is 1 in 3. That means that we took this path. And now, what's our chance of getting gray, given that we did take that path? As you can see from the tree, it's a 1 in 2 chance. So, multiplying straight across, we get 1 over 6. 3 times 2 makes 6. 1 times 1 makes 1. Does this agree with the outcomes that we see in the sample space? How many successes do we have for white then gray? Just 1 success. It is this one. Okay, great. So apparently the multiplication rule does work. And we should now try to find the probability of selecting gray twice. And this one should really make it clear how the conditional part is so important to this. First, we want to write the probability that gray is first. Well, that's easy, just 1 in 3, right? Now we want to multiply by a probability. But what is it? Gray is second, given that gray is first. Okay. If we take the gray path on the first pick, what chance do we have of getting gray on the second pick? Well, there are grays, certainly, that appear in the tree, but there aren't any grays in this part of the tree. So what's our chance? 0 and 2. Multiply them 2 together, 0 over 6. You can't get the gray marble twice because it had been removed and not replaced.